This video is on the objective convert from rectangular coordinates to polar coordinates. Alright, so I'm hoping that you watched my first video on this objective. That was a reasonably long one, about half an hour. I did several examples and drawings. This one I'm just going to go in and do it. We'll work on a problem where we are given the coordinates of a point in rectangular coordinates, Cartesian coordinates, x and y, and converting to their polar coordinates. Right? How would I get there with an r and a theta? All right. So again, if you want to see more about the topic, click on More Instruction. Look at their videos, their notes, their examples, and hopefully those help you. Alright, so here we're asked to find the polar coordinates of a point with Cartesian coordinates or rectangular coordinates, in x and y, of negative square root of 2, comma, negative square root of 2. Alright, so I'm going to draw a picture of this, right, where would this point here would be located in quadrant 3. So I'm just going to do that, put some point in quadrant 3 and mark it with these numbers. Alright, so here's a piece of paper, and I'm just going to draw some axes, vertical axis, horizontal axis. This is the x-axis in rectangular / the polar axis when we're talking about polar coordinates. And this is the y-axis when we're in rectangular, and it has no name at all, doesn't mean anything in polar coordinates. Alright, now the point we're given, the x coordinate and y coordinate of this point are negative square root of 2 and negative square root of 2. So that'll be in quadrant 3. So let's say this is negative square root of 2 on the x-axis, and this is negative square root of 2 on the y-axis. So we're talking this point right here in rectangular, right? That's, see the traveling on a rectangle to get to that point. All right. What I want now is, what are the value of r and theta in polar coordinates that would take me to the same location. So remember, in polar coordinates, here's the pole, the origin. We're traveling on circles centered at the pole. So I would first like to know what's the radius, of this circle that this point is on. And I'll draw that circle in, right? A little dotted circle. And again, bear with me here. It's not going to be the greatest looking circle in the world, but very, very rough circle. So here's this circle with a radius that I'm traveling on, centered at the origin. Down here, this will be the value of the opposite of r on the vertical axis. Over here is just the value of r on the polar axis. And here's the value of r on the vertical. And here's the value of, the opposite of r, negative r, on the horizontal, on the polar axis. And then the angle that we'd be looking for. Now again, you can draw the angle in several places, but typically, remember, usually when we draw an angle, when we think about angles, we think about it from the positive horizontal axis, so the positive polar axis here, and then going, counterclockwise for positive angles. So we're talking this angle here. Right, so I want to know what's this value of r. I'm going to try to find a positive value of r and a positive value of theta that take me to this point, right, traveling on this circle. Okay, so we need a few relationships. Now, these came up in the last video. I'm not going to develop these again. Just going to remember that r squared, right, the radius of the circle squared, will be equal to the x-coordinate of our point squared plus the y-coordinate of our point squared. And from this, since we know x and y, we can find a value of r. So this is, negative square root of 2 squared plus, and then again, negative square root of 2 squared. And this is simply 2 plus 2, which is 4. So we have r squared equals 4. Now remember, that means one of two things. R could be positive 2, or r could also be negative 2. Right? Both are valid. Both are valid when we're talking polar coordinates. So I'll write that on my picture. Right? Here's where r is positive 2 on the polar axis. And here's where the value on the polar axis is negative 2. Right? All right. Okay. Now let's talk about theta. Let's talk about the angle. Now remember that any angle I use has to satisfy this equation. Right? The tangent of whatever angle I choose has to be equivalent to the y-coordinate of my point divided by the x-coordinate. So that'd be negative square root of 2 divided by negative square root of 2. But anything divided by itself is simply 1. So we're looking for solutions to this equation. Now it's very easy to solve a simple tangent equation like this, right? I just need to think of one angle that works and then just keep adding pi, right? Because remember, remember the period of tangent was pi. So one angle that would work, theta, would be pi over 4, right? The tangent of pi over 4 radians was 1. And then I could add any multiple of pi, right? K times pi, where k is some integer. Right, and that's the value I'll start with. Right? Now let's see if it works for our choice. Now we choose which r we want. Right? So I'll keep the picture up. So what if r was positive 2, right? What if I chose this one? Right, if r is positive 2. So let's locate that on the polar axis. So that means I'm starting here. Right, that means I'm starting here when I travel around this circle at r equals positive 2 on the polar axis. Now let's see, does pi over 4 work for the angle? Well, let's see. If I start here and travel on this circle, and sweep out an angle of positive pi over 4, 45 degrees, I would end up just here, which is on the exact opposite side of the circle. Right, here's r equals 2, theta equals positive pi over 4. That's definitely not the location I'm looking for. But I can very easily get there. Remember, I just keep adding or subtracting pi. Well, if I want to keep my angle positive, I'll keep adding pi. So pi over 4, when I start at r equals 2 and sweep out an angle of pi over 4, well, that doesn't get me there. But then I just simply add pi, and I'll be there. And pi over 4 plus pi would be 5 pi over 4. Right, so theta equals 5 pi over 4 will totally work. It gets me to that point when r equals positive 2. All right, so this point here has the coordinates 2 for r, and then 5 pi over 4 for theta. Or you could just keep adding 2 pi to this. Remember, if you take 5 pi over 4 and add 2 pi, you're back there again. So that would also work. Or subtract 2 pi, you're back there again. Right? But 5 pi over 4 is fine. Now you could also have done this with r equals negative 2. And I'll do this in a different color this time. So what if r were negative 2, if I chose that for my r? So that means I'm starting here, right? I locate negative 2 on the polar axis, and I'll start from here and sweep out an angle. Now this time, would pi over 4 work? Well, if I start here and go positive pi over 4, remember that's counterclockwise, pi over 4 radians, so that's going this way. Halfway through this quadrant, there's pi over 4. And yes, that indeed would stop at that point that I'm looking at. So if I started at r equals negative 2 and swept at an angle of pi over 4 radians, I indeed land at this point. So I could also say the polar coordinates for this point are -2 for r, and then positive pi over 4 for theta. And again, if you wanted to, you could just keep adding 2 pi or subtracting 2 pi to this pi over 4 and get other angles, but this would be fine. So this would also work. But for the most part, I think they're going to want a positive value for r and a positive value for theta. That's between 0 and 2 pi. I think for the most part, they're going to want that. All right, so we have 2 and then 5 pi over 4. And that's this first option here. Takes me to this same location as this, again, when we're given rectangular coordinates, that points at a location. These polar coordinates also take me to the same location, just on a circle instead of on a rectangle. I'm going to read through the answer explanations and all this. Cool. All right, so again, hopefully watching me do this, looking at the more instruction if you need to, reading the answer explanations when they come up, right? I'm hoping all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.